Oh, it's not there. Yeah.
What was the name?
Races or something like that?
Yeah, it was
Races.
like that Turkish president.
Iranian.
No.
Yeah.
I
It was Iranian.
That's totally true. Okay,
100%.
so today we're talking about POSIX threads. POSIX is like a well, portable operating system interface. Like the idea is it's a certain kind of thread, whatever, threads that are defined for Linux. In the Unix environment, a thread has the following characteristics. It exists within a process, obviously, right? A thread, you know what a thread is.
Yeah.
Rigid operating system. That's why it's a prerequisite. Has its own independent flow of control. What that means is like it has its own stack. It as it progresses, it knows where it is, or when its own PC, right? Yeah. As long as its parent process exists and the operating system supports it, it exists. In other words, if you kill the parent, the child, it's not independent. If you kill the parent, then all the threads of that parent will die. As opposed to processes with fork, where once you've created a fork, it's a child, the father can die and the child will live on. It may share the process resources.
Say it again. You say
The fork, they're independent, so if the father dies, the children will live on. Here, it's not like that.
oh, POSIX threads are different than.
Fork is processes. We're talking about threads. Threads and processes are not the same thing. May share the process resources with other threads. Every process can have multiple threads in. That's the idea. Dies if the parent process dies. We said that over. Here it calls that a user thread because the operating system has no way of maintaining the thread without the parent process. Whatever. It's complicated. There's a question: is who's managing the threads? Is it in this user space or the kernel space? We talked about that in operating systems, but we didn't understand what we're talking about. Did I teach you operating systems?
Yeah.
Yeah. It's a subtle. It really pthread attributes. So we're actually just talking about a thread can possess an independent flow of control. It can be scheduled because it maintains its own. In other words, what makes a thread unique from other threads? First of all, it has a stack, its own stack, because otherwise it couldn't call functions. It has registers. It has scheduling properties such as policy. You could give one thread more CPU than another. It is a set of pending and block signals. In other words, a thread can choose to, like we learned about signals, it can choose to block a signal and not accept a signal, or it can accept a signal. And there's also some other thread-specific data. So how do you managing threads? Why threads? Managing threads requires fewer system resources. Now this pthread creates a thread as opposed to fork, which creates a process. But if you use fork, you have to create more strain. You create more strain on the system. The system has to do more. It's a heavier thing. All threads within a process share the same address space. For example, this is one of the things that makes threads easier. They use the same memory. The address space would mean memory space. So, for example, a global variable is shared between all the threads. It's only one. How can it be shared? Because they're all in the same memory space. They have access to it. When you create a process, so he has his own memory space, and you couldn't share a variable because he has his space and you have your space. They're each independent things. That's why we have a special thing called shared memory to specifically allow processes to share. But without that feature, without requesting special thing called shared memory, a normal variable would not be shared. But in threads, they can be as long as they're global. Communication is easier. Okay, there are three things that we're going to explain. One is thread management, one is mutexes, and one is condition variables. So first of all, how do you compile a thread? It's just like normal compiling, but you have to add the special flag -L pthread. Like a library, I think L stands for library. You need to have the pthread library in order to use it, and you need to include pthread.h. Now, the first function we're going to learn is the main function, which is pthread create. That creates a thread. maybe I'll skip ahead a little bit here. Let's skip ahead to where we see it's used, and then we'll go back. Here's a program in C, where you see I create pthread create, and then it takes a parameter called threads. Notice it's the address of threads t, because I instead of creating one thread, I created 3 threads. I did 3 number of threads 3 in a loop. So I ran this 3 times, and each time I'm giving him a different element in the array threads, and threads is a pthread type. Essentially, think of it as an integer. We just call it pthread type. It's like a special type, but it's really just integer. So basically, I made an integer array of 3 integers, and these integers do they have values? No, they have no values. They're garbage at the moment. We didn't assign them. We created them. We didn't assign them. What do you call them? Initialize them. We didn't initialize them. They're uninitialized variables, which is very weird. Why are you using an uninitialized variable? They're uninitialized, and then here we send it uninitialized variable number 1, number 2, number 3. We send it each time. Each time we do pthread create, we give it an uninitialized integer. But notice there's an ampersand. The ampersand means we're giving it the address. So this is this C style. I don't know if you use it much in C++, but it's a style in C in particular to pass a function a uninitialized variable, but the pointer to it, the address of it. And then what the point of this is that the function will assign it, will initialize it. The function's job is to initialize it. So I give it like an uninitialized variable, but if I would just give it the actual variable, then I wouldn't get back the value that it assigned it. So I give it the pointer to it, the actual, so it has direct access to the one outside. You know what I mean? In functions, you pass a pointer, then you can actually have access to the thing. So I passed a pointer to it. So now this pthread, what it's going to be? It's going to be the ID number. So the thread is going to be like ID number 113, 114, and 115, whatever the numbers happen to be, and I'll be able to identify it by this array. The first element in the array will be the ID of the first one, and so on. That's the first thing I have to give this function. This function takes 4 parameters. Second thing is null. We don't really care about that. It could be other things, but we don't care about it. The next thing we do care about is the print hello. What is that? That's the name of the function I want to run. It's like basically a function. It's called a function pointer, which means it's a pointer to the function that we want to run. And notice there is a function, in fact, called print hello. Now this function has to be a very special function because it must be defined with the following signature. In other words, it must have a void as its return variable, or a void pointer, and it must accept a void pointer as its. Now, a void pointer. Did you learn about void pointers? What is a void pointer? Well, type is void. In other words, it's not int, it's not float, it's void. So why? And it's a pointer. But what is this special type called void? So what it is, it's a wildcard. It means that it can return anything, but it has to be. But you have to know what you're doing. In other words, you as the programmer, in other words, I could return an integer here. I could return an integer in this function, and then all I have to do is cast it to void star. So the function is like allows me to return any type I want as long as I cast it. I'll cast it to a void star, but actually I don't even have to cast it because
The void means you didn't have to return. That doesn't return anything.
No, when it's a star, void means it's not returning anything. When it's a void star, it means returning a void pointer.
Where is the return?
In this function, it didn't actually do it, but it could have.
If there's Pthreads, this is not.
I don't think it returns it. I could have written return. I wrote some fun programs that did do that. I don't know if I think I have them here. I have some examples where I do return an actual value, but the point is, it is also C style programming. You return a void pointer, and therefore, you see, because when the guy who wrote pthread create, somebody wrote that, right? And the third parameter is a function pointer, but it has to be a certain kind of function pointer. What kind of function pointer? A function pointer that is a pointer to a function that returns a void star and accepts as a parameter a void star. In other words, you can't have like a generic function that can have any number of parameters. You have to be specific. So we'll be specific to a function which has a wildcard as its return and a wildcard as its parameter. So then I, as the user, can give it whatever I want. But I am limited. I can only give it one thing, one parameter, but it can be anything. I can give it a structure. I can give it a struct of 25 parts, like a class, 25 different elements inside it. But a single void pointer can point to that structure. I'll have to cast it. So when I use it, it's like a blank page. It's like a blank page. And then when I use it, I can decide what I want. So the next parameter is the variable I want to pass into the function. So the index here will be this t. Notice that I cast it to a void pointer. What is t actually? Well, this is a little bit filthy or dirty or rough and rugged and what is it? Rough and ready. What I'm doing is I'm actually taking an integer t and saying, no, it's a pointer. It's a void pointer. Well, I have to say it's a void pointer because it has to take a void. So I'm like, it's like I have a baby who I want him to eat broccoli, and I'm telling him this is chocolate cake, and I'm shoving it down his throat and telling him it's chocolate cake. I am saying that this t, which is really an integer, I'm saying no, it's a pointer. And the function just swallows it because he says, "Oh, I believe you. If you cast it as a void pointer, then it must be a void pointer." And then what I could do theoretically over here, but then look what I do over here. Look what I do over here. I take the index, and I don't even cast it. I just print. Look what I do. I take the index and I do d. D means decimal. In other words, I know that it's really an integer because I'm the writer of the program. I know that it's an integer, so I'm going to treat it like an integer, and I'm going to print whatever number I want there, whatever number he passed. You got it? So it's like I'm pulling the wool over his eyes, but as long as I know what I'm doing, I can do it. They say about C that it gives you enough rope to hang yourself. In other words, you can do what you want, and you can screw around as long as everything in the end matches up. You're okay. If I would, you know what I mean? As long as because in the end of the day, it's just zeros and ones, right? It's just zeros and ones.
Give it the wrong time. It'll be like, okay, sure, I'll take it wrong time. Yeah,
If you give it, because when you give it a pointer, what is it doing? It's saying, oh, this is an address of something else. So then it allows you to dereference it.
Yeah.
But if I give it an int, if you try to dereference it, the compiler will say, no, you can't dereference it. But if I say, no, this int is not an int, it's an address, it's a pointer, I cast it as a pointer, then I can dereference it. It's just, in other words, I can do whatever I want. I'm just talking to it's just me communicating with the compiler. I can tell the compiler, they give it all kinds of instructions, it'll do it. Okay, so you understand that this takes 3 parameters. Basically a blank variable here to get the ID, a null, the function I want to run, and the parameter I want to give it. And this function is just going to say hello world. Now here we wrote it all out, a lot of words here. We said the actual type is the pthread is a pthread type. Now that integer is a pthread type. And the null is actually the pthread attributes. So like I can define my thread. I've never given it anything but null, so I don't really know what else you would give it, but some kind of attributes. And the start routine, in other words, whatever, some void. And notice that this parameter must return a void pointer and accept a void pointer as its parameter and be a function. And then the argument, which is also a void pointer. So that's just the definition. And here we have a beautiful little function. And then we have this pthread exit. Notice what this does. This pthread exit is a special function for pthreads. And what it does is it allows the thread to exit without killing the other threads. Because you say, well, why should it? Well, if I would have written here, are you all familiar with the regular exit command? There's a regular exit command. I don't know if you're familiar with that. No, this is pthread exit. Yeah, here, exit, exactly. Exit -1. You familiar with that?
All right.
Well, that's a function that exists in C and C++ that lets you exit the program. So you could be in the middle of an if, and you could say if such and such, exit, just end the program. Usually you used to say return. Return just means return a variable to the function called me. And if it's the main, there's nobody to return to, so it exits, but it returns the operating system actually. But I can also exit directly. I don't have to return, I just say end. And here I end with the -1 to indicate an error. But a pthread exit, notice the pthread exit here and here. That just means this particular thread should finish, but in other words, let the other threads who are still running continue running. Don't because exit means exit on the process level. When you say exit, you're saying exit on the process. When you say pthread exit, you're saying exit on the thread level. So
Why need two pthread exits?
well, this is in the children are running this function. When the children well, actually, it's an interesting question. What if I wouldn't have the pthread exit here? The child would end, and it would be as though I did a pthread exit. It's redundant here. This is redundant because
At the end of
if I create a bunch of threads and then they die, it's not going to kill my process. The threads will die. Yeah, so explicitly say
as long as the function that you give it and the pthread create lives. Pthread create, you put in a function.
Here's the main, and then
when you said pthread create,
yeah,
part of that is print hello.
He'll only live as long as print hello lives. It's like that's how I delegated him a job. With the fork, I delegated the child the job by doing an if. If your fork value return is 0, then you're the child. So then do something, and then end of if, you're finished. Here, instead of using ifs, I'm giving him this function. His whole life, his whole world is self-contained within this function. Now, if this function node could access this, well, if there would be a global variable, there is some. But if there be a global variable, he could access it. But his world is that function. When that function ends, he ends.
It's like a mystery six.
It's like a what?
Mystery six.
It's like a mystery six.
Like a mystery.
It's like a box that you click and then a magical being appears and he does your goal. You give it a goal, say I want to do something, and then he does it for you, and then when he's done,
Disappears.
Yeah, it's exactly like that.
So before we hit the Mr. Beast, there has to be somebody who hits the button, right? There's
So I want to
somebody
explain something. I don't want to talk about this. I want to explain this. Pthread exit.
Sorry, I'm saying the create who gets the RC if everyone.
The main thread.
So the main thread continues after pthread.
The main thread, he ran this, then he went into a loop, and he did another one, another one, another one. Then when he finished, he did pthread exit. Now, what this does, this is very important. If I wouldn't do pthread exit here it is critical. If I would just do exit here in this last line, then the minute the main thread saw that, it would be exit, finish, or even if I wouldn't write anything. If I would just write return or just nothing, then he would end. Then when the main thread ends, all children die. So I must write pthread exit here. This one we said was redundant.
Why do you have to write that there?
This one says I am the main thread. I'm going out. I'm finishing my existence.
Does that mean that
The other one, but please do not end this process. Allow the process to continue as long as the other threads are around.
if there's only, let's say you didn't create any threads, just one.
Actually, it's
thread.
interesting. If I would get rid of this one, then one of them would become the main thread. Not sure if it's redundant, but whatever. It's certainly better to do it.
Return value.
What?
What's the return value of pthread create? Is it 0 for?
Oh, you're asking what's the return value?
Yeah, is it like the main gets.
On
0,
success, 0 is returned. On error and non-zero is value. So I say like this,
confusing.
if it's 0. This is if it's not 0, then there must be an error. If it's 0, then it's good. It is confusing.
Usually 0 is bad.
No, actually,
0 is usually.
no, think about it. Fork returns 0.
Yeah, that's
So,
it.
well,
That's it.
well,
I mean, that's only a parent.
Or
thing.
returns, right, parent gets.
Usually -1 is bad and anything else is good.
Yeah, or but if it's 0
So
or 1,
here-
0 is bad, 1 is good.
Or 0 is like nothing happened, 1 is something did happen, and -1 is an error occurred, so
Anyway,
something happened wrong.
I don't care what's normal, I just care,
Wrong
you know,
happened with whoever decided.
it's 0 means that it's success. Anyway, the point, you understand why I have this pthread exit here? Because otherwise I get a situation, a race condition, where the children were in the middle of what the printed hello and then print word, and then the father came to the end of the program and died, and now all the children are dead. So by this, I sort of relinquish control. I relinquish being the main thread, and I say whoever
If
is
there were no,
running can be the main thread.
if there were no create pthread, pthread create functions, there's just the one main thread. Right, you don't need a pthread exit.
No,
That's only.
it's only when you do P3.
So is the number of threads here that are created like that are all together in this program 4, one that creates 3 others? And it's not like it forks itself, right?
Yeah, if we would have a single process without any pthread create, then I would say there's one process which has one thread. It itself is the one thread in the one process.
So
And then once I created more threads, then I have I created 3, so I have a total of 4 threads in one process.
at the beginning, there's just one thread. There's one process with the one thread inside in the process.
You're repeating what I said, that you're correct.
Yeah, no, I'm saying, is that, I'm just confirming that.
What are you confirming?
That at the beginning, that it's made, the entity that reads pthread underscore t and all that, that's the main, that's a thread, that's also a thread.
Yes,
Right?
yeah, we'll call it a thread. Up until now, we didn't call it a thread.
Right.
But once we introduce the concept of threads, now we have to recognize that every process has one thread at least. So pthread exit, when the pthread exit is used, the main thread will stop executing. In other words, in the main thread, when and will remain a zombie status until all other threads exit. So he'll kind of sort of stay around to maintain the other threads. In other words, just if you are, because right, because if he would really go away, then one of the other threads would have become the main thread, and then which one is that? Which one? And then one randomly, and then he sort of stays around just to be like, he's finished, but he's a zombie. If you are using the pthread exit in the main thread, you cannot get the return status of the other threads, and cannot do cleanup of the other threads because you're long gone. You're a zombie.
Why?
It is better to do detached threads. Pthread detach. So that the thread resources are automatically released on thread termination. The shared resources will not be released until all threads exit. All right, whatever. I'm not gonna
think
test
the
it.
name zombie is a little mistake. Zombies are undead, meaning they were dead, now they're not dead. But
No.
it should be more like a vegetable, I think.
Okay. He's in a coma.
That's what I'm saying.
Pthread join. Now we have a new function in pthread join. And pthread join, let's see how we use pthread join. Imagine the previous program that we had, all of this, but instead of pthread exit right here, before we do that, we're gonna do the next thing. We're gonna do, you see, we here at the pthread exit, and in between, we're gonna stick this loop. And this loop is gonna go through where t is the number of threads, and we're gonna go pthread join, which means wait for thread, which thread? Thread number, the thread t, which is the ID we got. Remember we got the ID over here? We got that, remember we said that this array, where was the array? Threads is also unpopulated. We gave it threads of t. No, this thread of place, sorry, t is initialized. T goes up from 1, 2, and 3. But the array is uninitialized. So the array gets a value here, it gets the value of thread 0, thread 1, and thread 2. So now we're going to use that value. And we're going to say join, which means wait for. Don't proceed. It's like we saw wait by a process. Now we're going to call it a join. And that's a general term. In operating systems, we use that term. Join to the thread and also get its return status. Its return value is stored in this variable status. So notice that it's a double pointer. Anyway, is status defined?
Let's see, what does
It's
RC
missing
return?
here, but whatever.
What does it return? Because RC there matters. Not the right one. Yeah, here, if RC,
Right, if
so what is
RC
RC, what is
is
pthread?
not 0, then we have an error.
If it's not 0,
If RC is not 0, better be 0. If it's not 0, that's an error. But if it is 0, then completed join with thread number D. Well, that's T, the T that we.
Yeah.
In other words, number 1, 2, or 3.
wait,
And then the status equals the status that we got over here.
why would the threads, I thought the threads die. How could they join? They die.
No, because they did, the P thread exit, they finished.
Yeah, oh, meaning they exit and join.
They exit to wait for it to be joined. If there's a join, they'll wait. There'll be zombies also.
Vegetables.
So how do they get to the joint?
Those are zombies,
It sounds very similar.
because they come back from it.
Right.
So if there's a joint that comes, if they're
Yeah.
already exited.
Well, that's all, the only when they exit, wait, the join waits. When I do P thread join, I wait until somebody exits. Now, in this particular case, if thread, I'm waiting for him to exit, that's what I'm doing, that's the whole point of the join. I'm not gonna join him in the middle of his work. I'm waiting for him, because I might wanna synchronize things, I might wanna say, once all three have finished, then do something, or. This is a simplistic case, but a more normal case would be that when 1 and 2 finish. Then I wanna, let's say, then I wanna create thread 3 to deal with something else. But I want us to synchronize things. So in this case, I actually say like this, wait for thread 0, 1, and 2. And if thread 2 finishes first, I'm gonna be hanging around waiting for 0. Because I'm waiting for the first thread, specifically thread 0. I'm not waiting for any thread, I'm waiting for thread 0, because T is 0. And then when I finish and I found him, then I'm gonna wait for 1 and then 2. The order is gonna be set in stone.
And it's blocked.
It's blocked, it's gonna wait here to do a loop 3 times, and only when all 3 are finished, will. There's no way, I'm not sure, I don't know of any way to wait for any thread. And wait for just any old thread that finishes. I'm waiting for a particular thread. Which is T0 in this case, and then T1 and then T2. So if the order were different, I would never know about it. I'm gonna always print out in the order 0, 1, 2, 3. So this completed join with thread. It's gonna say 0 for sure. It's gonna be 0, 1, 2, 3, 1, 2. It's not gonna ever be 2, 1, even if 2 finish first, because I'm specifically waiting for 0. That's called synchronization, yeah.
Oh, there you go. You ever seen, you know the movie, Osmosis Jones? By any chance? Osmosis Jones.
Actually, no.
It's a movie basically about the human, it's a cartoon about like this white blood cell in a human body, who's a cop, and it's like a movie about it.
Long?
No, whatever.
20 minutes?
You watch the trailer. It's really good.
I don't wanna watch it.
No,
It's with Chris Rock. It's the way we're talking about Peter gives me the same vibes. It's like it's
Here.
we're talking about cells and like body parts and like different organisms,
and they split off and then
and they have like lives and like they do things themselves.
that's gonna be fun.
I don't know. It's hard to describe, but you look it up right now.
Yeah.
Just play it on do it on your computer.
No. What?
What? Hey, you're still recording.
I know.
Who did it?
Okay, so now we've already done operating systems, so you know about this problem of critical sections. For example, let's say thread 1, thread 2, and they're both trying to read a balance and deposit 200. We could end up having that instead of it going to 400 to 1,400, it goes to 1,200 because they each read the balance. And then only afterward did they add 200 to it. So he read 100, 1,000, he read 1,000. He changed it to 1,200, and as he took the 1,000 and also changed it to 1,200. So he updated balance, but it became 1,200. So in order to prevent that, we have something called a mutex, which we use with these, when we have multiple threads running in parallel, we want to organize them, or synchronize them. So we use a mutex, which allows you to lock something. Only one thread can lock a mutex variable at a given time. So if 6 different threads come along, only one can get the mutex. It's mutually exclusive. It's only one, as opposed to a semaphore, which allows multiple locks. So the workflow in general is like this: you create and initialize a mutex. Several threads try to lock the mutex, but only one succeeds, and it's called an owner. The owner thread then performs some actions, then he unlocks, then another thread can try to require, and this goes on. And finally, we get rid of the mutex, and we're done.
right? Is that necessary with destroying the mutex?
I don't know, I'm not sure. Mutex variable, you might, yeah, if your program goes, let's say your program is an operating system, which is gonna be running for 6 months without being turned off. You don't wanna leave the empty mutexes around. Mutex variables, right, if a program is gonna short-lived, it's gonna just run for a minute, then when it dies, it releases everything anyway. Hopefully, the operating system should do that. I mean, it also could, there could be a bug in the operating system, the operating system doesn't detect that you died and keeps it for you until you're gone. That would be bad. But a well-written operating system should get rid of all your resources when you die, but again, you can have a program that's a server. That's sitting there listening on a port for people to connect forever. Right, and the program's running forever, so then you better get rid of any resources when you finish. Mutex variables must be declared with type pthread mutex type. And must be initialized. There's 2 ways to initialize it.
What
Static is it?
Oh, this is a unit.
This is C. C in
Oh,
Unix environment. Static, you can either initialize them static by like this, you write pthread mutex t and then my mutex, and then you just do the static initializer. Or you can do dynamically, means with a function. So you do pthread mutex init, and then you give it the mutex that you created over here. And the attributes. This method permits the setting of attributes. We're always going to put the attributes as null, but if you wanted to give it real some other attributes, then this would be a better method. Dynamic. And then there's destroy mutex, free of mutex, but it's no longer needed. Mutex lock mutex is how you lock the mutex. There's now we're talking about the person who wants to grab it. Every thread will try to lock it, and only one will succeed. If the mutex is already locked by another thread, we'll block. We'll sit there waiting until we succeed. We'll wait. Non-blocking version is another function which is interesting called pthread mutex try lock, which obviously you're gonna have to periodically try, but you could like try to lock, and if you don't lock it, then do something else and then try again later. In other words, you could have a non-blocking function which just tries to lock. If it locks, good. If not, then it doesn't wait. It doesn't wait. It'll allow you to continue. It's interesting to think about what algorithms would be useful to have a try lock. Unlock the mutex. When you're finished, you gotta unlock it. You really gotta do this, it's obligatory. If the mutex was already unlocked, you try to unlock it, you get an error. It's owned by another thread. You try to unlock it, but it's locked by somebody else, you can't really unlock it. So now we have our example of a counter, and if we have 2 threads and they're both copying counter and changing and putting it back to counter, you might have the same synchronization problem. But we're gonna put a mutex so that we lock it, and A does his job and B does his job. They're just a little bit confusing because here you saw the left or right, and here it's top and bottom. But the point is, this is the top is one thread and the bottom is a different thread, and either they're both using the counter, which is shared. Because remember, we said by threads, any global variable is shared. So therefore, we can have collisions. Therefore, we need to lock and unlock. Here's one of my confusing programs. I like confusing programs. But this one's not so confusing. Print me. Here's a function called print me. And hi, I am thread number D decimal I. And why did I call it IP?
Oh, there's in I. There's already use IP to make I.
I guess I just used So what do I do here? This is, oh, actually I want to show you, this is also a useful style of programming that, I'm teaching also a little bit of programming styles. And this is a very useful style because, look, this, it has to be a void pointer, right? Remember we said that? Print me has to be void pointer, void pointer. So I am a good child, I do what I'm told. If it's void pointer, I make the function as void pointer. That's really, but instead of which, the other example I had where I cast it, yeah, I cast it. And now, when I call it, Here, what do? I give the value print me and I do vals plus I. What is vals? Vals an int. And then does vals have a value? Oh, but vals is not an int. Vals is a pointer to an int. And look what I did, vals plus I.
It's an array.
Vals is an array. But what happens when you take the array? This is, I'm showing you a very clever program. When you take the array name, what is the array name? It's a pointer to the beginning of the array. If I add I to it, then it's a pointer to the, it's also a pointer. It's a pointer to the next one. This is called pointer arithmetic. You did this in Shana Aleph, where you went through an array and you accessed the variables by pointers and not by indexes. But here we're going to see a usefulness of it, because this function needs a pointer. So I'm going to give it my pointer to the thing. I made an array of values and I gave it not the pointer to the first one, the pointer to the plus I. Well, the first time it'll be 0, so it'll be the first one. It'll be a pointer to the beginning of the array. Then it'll be a pointer to the next element, next element, next element. And each time I put in that location vals of I a value. So I give it a pointer to 0, a pointer to 1, a pointer to 2, and a pointer to 3. See how I'm doing it? This is like beautiful. This is the way it was do it. I'm giving it I didn't have to do any casting in this case, because I didn't have to cast it because a void pointer actually doesn't have to be casted if you give it a pointer. You only have to cast it like I did in the first example because I gave it an int. And there's a conflict there. When you have an int, it's like broccoli and trying to tell them it's a chocolate. But here, a void pointer there's a such thing as a void pointer. It's a placeholder for any type of pointer. So I'm giving it a pointer, so it works perfectly. So I give it a pointer. Now it's a pointer, right? So first I create an int pointer, because this pointer, I happen to know that it's an int pointer that I got. But from the perspective of this function, it's a void pointer. So now I do some casting and I say, take IP, which is a void pointer, but assign it to I, which is an int pointer. Now I have an int pointer and I can just do a dereference on it and get the integer. If I tried to do this without this intermediate steps, I could have just taken this and then cast it to an int pointer. I could have done IP and then parentheses int pointer and then dereference it. But that is confusing to the reader, and you can screw yourself up. If you don't use the parentheses right, the star won't work. If I say that again, if you don't use the parentheses in the right way, then the dereferencing won't work. But the way I did it, I divided it up into steps so that it's very, very clear. I got this advice from a friend of mine who was a serious C programmer. And he told me to do it this way. I was just doing it with the dereferencing. Sometimes I made a mistake and then it would give me an error. This is the best way to do it. In other words, I make a new variable just for the purpose of dereferencing, just so that I don't have to do it in one step. I make an int pointer, and now I do the casting here and I get it done with. I'm finished with the casting, and now I have my I, which is a regular int pointer and has the value that I got passed. And now I can just simply dereference it and print it as an int. So hi, I am thread 0. Hi, I am thread 1. I am thread 2. I am thread 3. That's what I'm doing here. And I return null. Notice I didn't do pexit. I don't really need to. In this program, I don't need to, because the return over here is not going to kill the whole program. It's just going to finish. It's like I did pthread exit. It's just going to kill the thread. If I would have done exit here, it would have killed the whole program. But I didn't. I just returned null. Now I do. Wait a second. Now I do join. I'm trying to join. What?
Could you join if they didn't finish?
I didn't what?
If the threads didn't finish.
Well, the first join here will wait until the first thread to finish.
But won't they all go into that?
I do it 4 times. The first one, I will get. I'm here. I'm doing TIDs of 0, TID of 1. In other words, I'm waiting for a particular thread.
I'm saying the thread that was created at thread underscore create. Let's say thread 0. When it finishes with print me, it's going to continue and go to 4.
He's gonna become a zombie, and
Oh, he's-
he'll wait for this join to find him.
But why is he gonna be a zombie? All he did was return to the main.
He returned, that's like he finished.
He
No.
returned to me.
Yeah, but that's called finished. All he is a function, his whole life, we already said that, a thread's whole life is a function. Nothing else for him to do.
Can't continue.
Nothing, he is that is him. He is print me. Now I wait for each one and I'm done, okay. The output is hi, I have thread 0, 1, 2, 3. I didn't use any mutexes here. But I'll just show you another example. Trying to join with 1, join with 1, trying to join 2. Why does it say join with 0? It doesn't say trying to join with 0. But here it said trying to join with 0. Why did it say trying to join with 0 here?
That's the big clever guy.
Because the main thread happened to print before the other threads took some time to be created. So he went into the trying to join and he's already waiting. But only now does pthread 0 actually do something. And then he joined. Using pthread exit. So now I did the same thing, but I wrote pthread exit. Well, then I did a funny thing. I put a pthread exit before the joins. So then I'm gonna finish and it's not gonna do it. Yeah. So what's gonna happen here? Hi, I'm thread 0, 1, 2, 3. There. Now, even though he did a pthread exit, the other children can still run. Presumably he did his pthread exit before even the first one printed anything, but they still get to go. So, well, the output's like. Now using exit, I just want to show what if I use exit? Well, if I use exit over here, that's gonna screw up everything. And here I didn't do any pthread joins, pthread exits, or exits at all. So trying to join with 1, like the father quickly got to here, trying to join with 0. And then hi, I'm thread 0, and he exited, so it killed everybody. Okay, now a complicated topic which is called condition variables. Well, I don't like the example that I have. Sorry. Let's go back. Okay, condition variables, new topic. Moses Jones. Mutexes allow you to avoid data race by protecting an operation. They don't permit you to wait until another thread completes an arbitrary activity. Condition variables allow threads to synchronize based on the actual value of arbitrary data. In other words, when we say arbitrary activity, we mean the mutex says he freed something, and then I can go in. But what if I want? What if he's like doing something? He's filling up. He's counting. He's counting numbers. He's counting 1, 2, 3, 4, and I want to. The minute he gets to the number 100, I want to do something. He doesn't know that I'm waiting for that 100. He's just a thread counting numbers up. Every time he gets to 100, I'm going to reduce his number by 50. I don't know. I'm going to reduce his number by 50 every time he adds 100. And so he'll just be going back down. I'm going to do that. That's what I like to do. I have one thread that counts to 100, another thread that every time he gets to 100, pulls him down to 50. So how do that's called arbitrary. I want to do something based on an arbitrary condition of another thread. I mean, I could poll. Polling means that I check every 10th of a second is the number got to 100. And then something will get to 120, and then I'll notice, and then I'll remove 10. I'll remove 50. I could do that, but I want something better. I want to synchronize based on arbitrary data. Without condition variables, the program would need to poll. Just like I said, I need to poll and see, has this thing changed? And that would be wasting CPU. A condition variable is a way to achieve the same goal without polling. No busy wait. So. You see what I'm saying? Condition variables useful when a thread needs to wait for a certain condition to be true. In other words, that the number reached 100, or the number reached 1,000, or I mean, I'd like to think of another example. It's the only example I have in my head. And if I'm doing a condition, maybe another thread is I'll tell you, another thread is creating a socket, for example, and I want to communicate with it. But it takes, I want to know when he finished the socket. I don't want to keep, I could send a message to him through a socket every 10 seconds and then get, it won't succeed until eventually it succeeds. And I know he succeeded. Or I could just say, that when that thread is ready and he's got his socket built, then I want to start communicating. So that could be an example also. Where it's not I mean, there he can signal, but he doesn't know that I exist. Because it could be that there's many people that want to talk to that thread. There could be a certain thread that's building a socket for everybody to talk to. And how is he going to let me know? Maybe he doesn't know I exist. Maybe I don't exist.
Waiting for like a specific socket.
I'm waiting for a specific thread to create a specific socket so that I can then communicate. I don't know, for example, I'm trying to think of another example, but the simple example is
Right into the table and you're waiting for a specific data to be ready. As opposed to like.
so that, well, like I said, I kind of go 100, yeah. In Pthreads, there are 4 relevant procedure calls. Pthread condition initialize, destroy, wait, and signal. Well, initialize and destroy are kind of obvious. And then wait and signal are the other 2 things. I am waiting for it. Well, it's a little bit confusing here because it takes a Pthread condition and it also takes a mutex. I wait. We'll see how this works. There's a couple things at once, and then I signal. We'll see. Signal is free. So, Pthread initializer. It can be done dynamically or statically. Fine. Pthread destroy to free. Now, what does Pthread condition wait? Is called by a thread when it wants to block and wait for a certain condition to be true. It is assumed that the thread has locked the mutex, indicated by the second parameter. In other words, let's say there's multiple threads that all are waiting for this number to reach 100, and then they're gonna reduce it by 50. There's all these, imagine like they're like piranha fish. And they're all waiting for that piece of hamburger meat to be in the water, and the first one that gets it grabs it. So there's many threads. No, the meat doesn't know about the piranhas, and the piranhas are so the piranhas say like this: if I got the meat, then I want to lock the mutex. Nobody else is going to get that meat. It's in my teeth. I grabbed it first. I got it. There's no sharing of this resource, because if otherwise 2 people could try to remove 50 from the 100 at the same time, and they'd each think they got 50, but really there's only 1, and we'd screw up the data. So there's always a mutex, so there's a mutex involved, but the mutex is not to do with the condition. The mutex is an additional thing that I want to lock when the condition is true. So the way you do it is like this: first you lock, and then you wait for the condition. But when you wait for the condition, you unlock. We'll explain. So, it is assumed that the thread has locked the mutex first. Then the thread does Pthread condition wait. When the thread does the Pthread condition wait after having locked the mutex, he unlocks the mutex and waits for the signal to come. When it is awakened, it waits until it acquires. If it gets the meat, if it's the piranha to get the meat, then it acquired the mutex, and once acquired, it returns from the wait. But if not, then it goes back to sleep. Let's see an example. So here, look what I do here. pthread mutex lock. I lock the lock. Then I do pthread condition wait. Notice that there's a multiple threads here. What?
So all the threads are waiting.
Oh, is there multiple threads? Wait, do I see a loop? Here's the main, here's the loop. Oh wait, here's the loop. I create many threads. Here I create many threads. It's a little bit confusing progress. Everything was simple until now. Here's the function is called barrier. And notice that when I create it, I give it barrier and I give it ts plus I. Now what is ts? Ts is an array. Notice I do plus I. That's the same sheet I did before, where I'm giving it a pointer to an element in the array because it wants a pointer to an element. It wants a pointer. And what is this particular element though? It's an array of structs. T struct ts. Now, this struct has been defined over here as a type def T struct, and it has four elements. The ID is going to be unique to each one. The other stuff is not going to be unique. Because look what I do. Notice that I set her, this is a loop, right? I'm going through them all. Notice that the ID is odd, so that means it's changing every time. But notice that the other thing, the lock, is not changing. For every one in the loop, the struct elements are identical, except the ID. Here, the lock is the lock. What's the lock? It's the mutex. The CV is the condition variable. What's the condition variable? It created a certain variable. And the done, and the I think number done is 0. But notice that these are variable. Instead of using global variables, remember I said that threads share all global variables. Instead of doing global variables, here what I did is I used non-global variables, but I gave pointers to them. Notice pointer. So everybody is pointing. All 4 threads have a pointer to this condition variable, the mutex, and the number done variable. The number done variable, because they're gonna, as each one finishes, they're gonna increment the number done. So they all want to be pointed to the same thing. Of course, they don't want to increment it at the same time, so there needs to be a mutex to lock. And that's why we have a mutex. They're all using the same mutex, and they're all using the same condition variable. So these are all identical. And then I create and I join. Okay, so we got the basic idea of these condition variables, the locks, the mutex, the number done, and the idea of the thread. Now let's go back. Here's the struct just defined. Okay. And here's the function. So the function is going to get one parameter, but it's a structure. It's that structure that we got over here. And it's a pointer, fine. Now, notice that I did the exact same format that I showed you before. That's why I did all those things. So now you can understand this program. I'm using the same methodology. I'm taking this struct, I'm declaring a local copy of this structure. And I passed it as just a void pointer. So I have to cast the void pointer to my local TS. My local TS is just going to be an identical copy. Well, it's going to be a copy of all those pointers, so the actual it's going to point to the real thing, except for the ID number, which will be a copy. Because that wasn't set as a pointer, it was set as a variable. Anyway, I have my TS with all the parts in it. And then I say, I print out waiting for barrier, and I call it, I print out the ID number, the TS, which is what I created over here, the ID of it. Remember the arrow operator? Just like in classes, it means the thing inside. So I get the ID. And now I do this procedure which we discussed in the notes. I say lock the mutex, because if I'm going to do something like change the number of done or something like that, do I change the number of done? Yeah, see, I changed the number of done. First, I lock the mutex. So In other words, I got in, I was the first one in, and I said that the number of done equals the number of done plus one. I'm finished. It's a kind of stupid thread because really in between this first line and the second line, you should do something. The critical, right? You should do some useful work. Here he's not doing anything useful, he's just saying I'm finished. So he says I'm finished here. Then he said, if the number of done is less than the number of threads, in other words, if I'm not the last guy, if I'm the last guy, then fine, then do this. But if I'm not the last guy, then wait here, then condition wait, then wait for a signal on this condition variable. Wait for this condition variable to be signaled to the signal variable, the condition variable doesn't have a real value. It's just like a, well, I mean, it does have a value, but you don't think of it as just like a wet, a red towel. Somebody says, I'm waiting to get the red towel. Waiting for somebody to signal me. Now, nobody has signaled yet. So but now I don't, now if I would continue holding the lock, then I'd be in a really bad situation. I have what's called a deadlock. I would be waiting for the condition for somebody to signal me. And I'd be holding this mutex lock here over here, this TS lock. And I would have locked it. And nobody else would be able to increment the done to the next number, and the next number, and the next number. It would never advance. All the other people we locked out. I locked it, I incremented it by one, and then I waited, I didn't unlock it. So there's a special feature of this control Pthread condition wait that has a second parameter. And the second parameter is the mutex that I'd like to unlock. So I actually unlock the mutex here. I wait and I unlock it. So now somebody else can come in, he'll grab it and lock, go in, change the number, but only one guy will go in. He'll go in and wait and unlock, and then the next guy will go in. All four of them will wait and unlock. Now, if the number of done is no longer less than the number of threads, which means it is the last one, then he won't wait for this condition. He will immediately go over to here and say signal on the thing. Now, when the signal on the thing happens, he will now this is a little bit confusing here. He will actually, here, you know what he'll do? He will actually grab the mutex again. When I signal him here, he will grab the mutex again, even though it's not written here. He'll grab the mutex again and then proceed. And that's why when he proceeds, he'll skip the else and he'll go to music unlock. In other words, imagine a scenario like this. Imagine that he goes signal, 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 signals everybody in the wink of an eye. Now all of a sudden the first one notices that he got signaled. But it'll still be sequential. It'll still be one by one. We don't know the order, but it'll be one by one. They won't all be woken up at the same time. One will get the signal. He will grab the mutex. Maybe they'll all get the signal. I could actually do. There's another command we didn't show here. It's called Pthread condition broadcast, where I wake up I signal everybody. And if I could signal everybody, but still what would happen is that only one would grab the mutex, and he would come over here, and then he could do some other critical section. In other words, he's been notified that this event has happened. Theoretically, after this line here, I could do something else that I want to do when the condition has been met. The condition is all of them have finished. All of them is finished. Now I want to do something. So I can do it after this line. I do it after this line. And then I unlock and let somebody else do it after this line. So it's like it works together, this signal and this mutex. So that's why this mutex unlock is required here. And then the original one also will do. Actually, I'll tell you even more. I'll tell you even more. The first one came here, and he signals. Nobody is going to do anything yet, because they're going to get signal, but then they're going to wait for the mutex to get unlocked. But who's holding the mutex? The last guy. So he'll come here and unlock it, and then boom! All these guys have been signaled. They're all scavenger fish trying to get it, and they'll grab. The first one will grab the mutex, and he'll do nothing and unlock it. Second one, grab mutex, will do nothing unlocking. It's kind of stupid program, really.
But doesn't the last thread unlock sequentially?
Last thread
Because
unlocks.
Four I less than n threads. So let's say number 4 gets there, and then he goes, alright, signal, and then number 1 who's been waiting over there, skips the else, and he goes to the unlock.
Yeah. No, but when he skips, he's already grabbed the mutex, so when he does unlock, it's no problem because he's locked. In other words, the code, you can read the code straight. He locked it, he did all this stuff, and then he unlocks it. The other one locked it, and did all the stuff. The fact that intermittently, the condition variable has two hidden functions. The two hidden functions are that it unlocks the mutex the minute it starts waiting. And the second one is that the minute it stops waiting, because it got a signal, it relocks. But it only relocks if it can relock. And it only can relock if the mutex is available. If somebody else has grabbed the mutex in the meantime, in between the signal and its attempt to lock, if somebody else is locked, then it won't lock and it'll wait.
So for the signal, the last thread 4, when he goes to signal, does he grab the mutex? Does he grab the lock?
The last thread will grab the mutex, see that it is not less than a number of threads, and start signaling the other threads. They will get woken up, but they will not proceed because they can't proceed until they get the mutex. Then that last thread will release the mutex. Then whichever of the 4 that were released is able to grab it first, grab the mutex first, will grab it, and then he'll proceed, he will skip the else and go immediately to unlock and let somebody else grab it. And let somebody, so you don't actually see there, it would have been nice if there'd be a line after this pthread condition wait to actually do something interesting. And then you would see that that would be done in order, in a random order,
Why would it be written?
Because here he just signaled everybody.
Yes, but the first one has been waiting to be first.
No, it's like those fish in the tank, they're trying to get the answer. The first one,
Anyone can receive the signal, and anyone can.
no, he signaled a particular one.
Say any
Oh,
of the
wait.
threads that are waiting.
No, you're right, he made 4 times on the signal. So there were 4 people they all got signal. But only one will get the mutex,
And it can be any one of them,
and it can, there's no order.
so it'll go 4 and then 3, 2, 1 are just random.
Well, look at this, wait. But here you see the order is 0, 1, 2, 3, 4. And then 0, 1, 2, 3, the order does seem to be kept, but I'm not sure if that's really true. Oh, yeah, it is true, because look, wait, no. Because, yeah, look. It is true because of the print. Oh, thread after the barrier. Yeah, it does seem to be in order. I'm not sure. I'd have to test this again.
So the signal goes to the one who's been waiting.
I don't think it's in order. I don't think there's any order kept. I don't think there's a queue made. I don't think there's any like first come, first serve.
Once anyone, any
But it
number of
does seem to
threads
say-
are waiting, they can all grab the one.
Yeah, I think this order here it could be 4, it's certainly gonna be 4 first. But then it could be anybody at 0, the 0 place could be in my opinion, I have to test it.
But not like the signal, do they go to specifically who's waiting? Meaning even if another process could hypothetically get the lock, sorry, one, let's say thread number 2, hypothetically get the lock, but he doesn't have the signal, his signal yet. Are they specific like that or no? So it's just random, it's arbitrary.
He gets the signal first. You can't grab the mutex again until he got the signal. Alright, let's go on. I have a couple more things to show you. Isn't this nice and complicated?
This is neat, this is actually very structured, I like it.
I can add, yeah.
If you could split up threads and make like a lot of them, then it should be able to put them back nice and neat.
Yeah, when do we finish today?
So with the lap, no lap, right?
I don't think we have a lot. We finished the last. Anyway, I want to finish this slide. Return a value from a thread. The return type in the thread definition must be a void pointer. We saw that. but we can cast to whatever type we want. The pthread join gets a return value from the thread. It uses a reference to a pointer to receive the value. This enables it to receive any value and cast it to a local variable. When passing a reference back from a function, that reference is to a local variable in the function, we'll get a segmentation fault. You see why? You can't give a pointer to a variable that's gone out of scope. So in other words, if we want, let's say we created a variable in our function and we wanted to pass it back the value of it, we can't. Because, well, we could pass it, we could trick it and pass and cast it as a pointer, but really give it a value. But let's say we wanted to work normally and give it a real pointer. One solution is to dynamically allocate a variable and return a pointer to it. See the next slide. So look what I do here. Here I have my main. And look what I do. I call create roll dice. Roll die. Look what I did. I tried to think of I run it to roll if. What is this? Okay, wait, what did I do here? I made a pointer called result. And then I did random. I seeded the random. Then I made a thread, a single thread. And then I rolled the die, single die, and if it's not equal to 0, what did I say? If it's not equal to 0, then it's an error, so n should equal 0. And then I said, now join, and I got the variable back, res. Now res is actually a local variable here, so my res is now pointing to something that exists in the other function. The other function, right? Notice I cast it null. I didn't give it anything. You understand what I did? In the other examples that we saw, go back to the first example we saw. Index. Here, I passed it. Where's pthread create? The last parameter is t. But look at this example. The last parameter. The last parameter that I passed in is null. I didn't give it anything. I gave it nothing, but I want to get something back anyway. So look what I do. I get back something. But when I wrote something here, I gave it the address of a pointer. Not the address of a variable, the address of a pointer. It's like a double pointer. That's why the type is void star star. That's actually the way it's defined, as a void star star. Now, in the function, what did I do? I rolled a die. Why rolling a die? Because rolling a die is a way to create a number. I want to create a number out of thin air. Normally, you pass something in and you get something back. How do you have a function that doesn't get anything but gives back a number? So I made the logical thing is a random number generator. So I did a random number generator. I got some random number and I called it result locally. And I say malloc. Malloc is memory allocation. So I allocated real memory so that when the function ends, the variable will not get wiped out. Because normally when a function ends, local variables are lost. But here, not going to be lost. So I said like this, malloc, make it int. Result equals the malloc. So I have a local variable called result, which is pointing to an int. So now the content of that pointer should equal the value that I got. Okay, fine. So far, fine. I have a simple integer called value. I assigned it to this result that I've created, and it's a pointer to an int. And the value, the content that it's pointing to actually has this value. Now I do return result. What is result? It's a pointer to an int. In other words, I returned an address an address of where that thing is, where that value is. So now. This, I have to, so I say. I returned an address, give me the location of that address. This is taking a location of an address, the address of an address. This is the address of an address.
It'll give it status.
The Kitzer, when I say, give me the content of result, I'm gonna get the actual value. And then I have to remember to do free on the pointer, because otherwise I'll have a memory leak, right? In other words, except I don't really have to because the function ends anyway. But to be nice, I'm just showing you that you should do free on it. The point is, I was able to get back a number, I was able to get back a real thing from a function that I'm showing you basically how malloc, in other words, you probably, I don't know if you ever did that in C++, where you make something, you make a function that creates a variable and then you pass back the pointer to that variable. Probably did.
C++, I know there's like L and R values, but it usually does not like that. I mean, you usually can't, unless you do malloc, I think it does not like that.
All right,
Ask a question.
Yeah.
The result, when we get the Pthread join, that parameter, the first one, what's the first one? First one is,
this is just the ID.
okay,
Notice pthread type D,
oh, yeah.
that's like the ID.
My second one, how do we get, how does that translate to the return type of the original create,
Well, it's basically like this. If I would not write an ampersand here, then what would this be? This would be. Then this would be just a pointer to an int. But this pthread join is defined to get a double pointer. So I make it a double, so I get the address of it, and then it's a double pointer.
so Pthread join gets as its second parameter, the return type of the original function that was called with the corresponding Pthread create.
Should try running this. What?
The second parameter in our join, the join corresponds to the return type of Pthread create. With like, we don't have to set it up. It just.
You mean this th? Oh, this th and this th?
Yeah,
Why is this an ampersand?
no, I'm saying so that the return type is the second parameter.
Yes, this is the return type.
Of the original function.
We never did that before, but I think I have another example.
Status, we said status, I don't know what that matter, how it gets.
Here I do with passing a parameter. Oh, where is passing a parameter? Looks like the same thing. All right, I don't have to do the last example.
What are functions in temporary protect? I never sure about.
All right, we'll stop here.
So what's the structure of the